Welcome to your online coffee break, where we discuss bite-sized topics that inspire, educate, and entertain. Here's your host, a software innovator, award-winning marketer, and astronomy and space buff, Chuck Fields.
Hello, thanks for joining us for your online coffee break. Today I'm here with John Ventre. John is a historian at the Cincinnati Observatory, which is where we are now. Beautiful historic building in Cincinnati, Ohio. John, in addition to being a historian, is also a personal friend of mine and has been a mentor of mine for years. As a matter of fact, we met several decades ago when I was at the young age of, I think, 14 years old, and I was a budding astronomer, and I had lots of questions. And John was a member of, and still is, of the Cincinnati Astronomical Society, and he sort of took me under his wing with a lot of other fantastic mentors out there, and they helped teach me the ropes of this wonderful, beautiful hobby of astronomy. So I just want to thank him. Thank you, John, for taking time out of your busy schedule to join us. Thank you so much.
Thank you for coming back to the observatory and visiting. And
I love this place. Of
course, when you were a teenager, you were truly an exceptionally fine young amateur astronomer, and that's why we enjoyed working with you. Yeah.
Thank you. I'm blushing right now. But if you're a parent of kids, or if you just have this astronomy bug of your own, especially with the recent close approach of Mars over the summer, I highly encourage you to reach out to your local observatory or astronomy club. If you're in the Cincinnati area, by all means, come to the Cincinnati Observatory Center and just let that hobby blossom. So, John, today I want to talk to you about a sky phenomenon we normally see. My wife and I were driving a few weeks ago, and we noticed this beautiful rainbow, and it just wasn't an ordinary rainbow. It was a double rainbow, and we stopped, we took pictures, just really loved just the beauty, the vivid colors and everything like that. John, tell us more about rainbows. What causes them?
Well, they're magic, obviously.
They are magic, and there's a pot of gold at the end. Yes, I know. We're going to be rich people after this. Seriously, what causes the rainbows that we see in the sky?
Well, let's back up just a little bit on that one. Mm-hmm. I enjoy looking at rainbows. Evidently, you and your wife enjoy looking at rainbows, and I find that with most people. Mm-hmm. Well, I was fascinated with them, and I started asking people, tell me the story of your most memorable rainbow.
Right.
And everybody has a story. They all remember it. And then when I started putting the picture together, I realized that just about everybody would see their rainbow late in the afternoon, early evening. Mm-hmm. The sun was setting in the west. They saw the rainbow in the east. Okay. And I started scratching my head and say, well, how does a rainbow be so smart that it knows always to show up at the late afternoon or early evening hours?
Right.
So then I started going to the books, looking at atmosphere, phenomena in the atmosphere. And at that time, there was not much written on rainbows.
I bet.
But over the years, you just sort of build up a series of articles and collections and things in physics, and it is truly a scientific phenomenon. It relates to the atmosphere, it relates to physics, it relates to mathematics, and it all ties together in science, and that's why I like it.
Sure. Well, speaking of that, what was your rainbow experience? What was the first rainbow that you saw that really captivated you?
I was probably a teenager, backyard of the house. Of course, it was late afternoon, evening, and the colors were just so unbelievably vivid. I mean, it was just not a hint of a rainbow. It was there. And it was truly a beautiful arc, and it was almost a full arc, the color going all the way down to the ground level.
Really?
Yeah, it was gorgeous.
Wow.
Still remember it.
Now, what I love, and you pointed out that rainbows are opposite the sun in the sky. Are there common times or common places where you're more likely to see rainbows than other times?
Well, since my first start inquiry, I realized you need raindrops to make rainbows. Okay. So typically, rainbows will occur when people see them after a shower. And when we get our showers, mainly late afternoon as the moisture raises in the atmosphere and the showers, you don't get many in the morning, but they can occur. They can occur.
Sure.
If you get all the phenomena, the sun, raindrops, a rainbow probably will occur.
Okay, and that's the thing too, because my wife was pointing this out. She said, I thought you always go out in the rain to look for a rainbow, but it's generally after the rain, of course.
Typically after, or maybe right before, the beginning of a shower, sometimes I will notice them.
Okay, well, what causes a double rainbow? And are there such things as a triple rainbow, or can you take that double rainbow and just stretch it to one big rainbow? So what makes a double rainbow in the first place?
Well, let's back off just a little bit
Sure.
and talk about a single rainbow.
Okay.
And then we'll take the next step to the
Fair
double.
enough.
Now, here's where I wish I had my blackboard and I could start making all kind of lines on a blackboard for you.
That's okay.
But let's do paint a visual picture.
Okay.
You have the sun setting in the west. The sun is shining on your back or the back of your head. And if you could take a line, create a line from the sun to your head, and then project that line out in front of you. Okay. We'll call that point the sub-solar point.
Okay.
Okay. Now the rainbow is going to form above that sub-solar point. And what's going to be is a combination of refraction and reflection of sunlight through individual raindrops. So let's just zoom in. We got one raindrop. You have a ray of light coming into the raindrop. That's refraction. It hits the back of the raindrop. That's a reflection. It comes back out of the raindrop. That's another refraction.
Okay.
So two refractions and one reflection. And if you put all the math together, the rainbow's in the sky. You got millions and millions of raindrops involved. Each raindrop is producing a rainbow or a part of the rainbow for a small point. Like my right eye sees a different rainbow than does my left eye.
Really?
The person standing next to me sees a different rainbow than I do because it's a combination of different raindrops that are involved.
Wow, I had no idea.
So then, because of the physics of it, when you pass certain kind of light rays through the tops of the drops, they refract out backwards through the bottom of the drops into your eye.
Okay.
So that is a normal rainbow composed of millions or hundreds of thousands of individual raindrops. Okay. Now, typically, because of the refraction, the bending of light, you produce a spectrum of light, the various colors of the rainbow.
Right.
And typically, the color red will be at the top of the rainbow. And then as you go down the line, red, blue, green, you got there are other colors at the bottom of the rainbow. Okay. Now back to your question, the double rainbow.
Right.
Well, let's go back to our individual raindrop. A ray of light goes through it, refracted. There are two reflections inside the raindrop, and then it comes out.
Okay.
So therefore, the color of the spectrum is inverted because of the two reflections.
Right.
So now the second raindrop will be on top of the primary raindrop of the rainbow, and the colors will be reversed. So red will now be on the inside of the rainbow. So red will match with red, then the colors will spread out in the opposite directions.
I did not realize that.
Pay attention to that next time.
Okay, definitely will on that. Now, there's some other things too. Again, rainbows are just so beautiful. But there's also some other phenomena in the sky that are caused not only by the sun but the moon. Let's talk about halos. What is a halo?
Well, very, very similar process. Some light, typically sunlight, entering either a drop of moisture, it could be dew or rain, or with bows, more often than not, it is ice crystals as opposed to raindrops. So just replace a ice crystal with a raindrop.
Okay.
But the ice crystals are very, very unique. They're formed in two main types. One of them I'll call a pencil shape, and the other I'll call a plate shape. They're hexagons. So think of a long, elongated pencil, hexagon shape, and then a plate with hexagon sides on it, thin like a pancake.
Sure.
Okay. But these are really small, fractions, hundreds, sometimes thousands of a millimeter, very, very small crystals. But light enters them, and you have the problem of refraction and reflection in these ice crystals. And there are probably a dozen to 24, I'm doing this from memory, different types of bows produced by light coming in at different angles. If it's a pencil crystal or a plate crystal, if it's coming from the flat or coming on one of the sides. All those math is here's where math comes in, produces these different kind of bows. And the light source typically could be the sun, but it could be the moon or some other bright source of light. It could be a reflection off of water, off of a golf course where it's dew in the morning,
Right.
off of a mountaintop. Or if you fly in a plane, you're looking down on clouds. Many times you will see these phenomena occur.
I've seen pictures of that
Yeah.
before.
All combinations, typically sunlight, ice crystals, sometimes water crystals. And you have literally hundreds and hundreds of combinations of the light sources, the type of material, drop or ice, the shape of it. Is it a small drop? Is it a big drop that produces different effects?
Right.
Yeah. So you put all that together, some beautiful, beautiful atmospheric phenomena.
Absolutely. Now, you mentioned ice crystals. Obviously, more common for me, and this makes sense now, is that I tend to see halos around the sun and the moon in the wintertime.
Ice crystals, yep. Especially in the sky, yeah.
Yeah, that makes a lot of sense on that. So typically winter is probably a more likely time to see halos than,
Yep.
say, summer months?
Yep.
Well, that's fascinating.
Now I have tuned my conscious and vision to look for these. And you can see hundreds of them throughout the year. You just have to know when the conditions are right, know where to look for them. And if you look for them, they're really there.
And they are beautiful.
Yeah.
One thing that I love personally, even the name alone just sounds great, are what's called sundogs. Can you tell our audience, how would you describe a sundog?
I usually see sundogs in the spring or fall, where you have ice crystals in the sky. It is a sort of a hazy atmosphere, and many times the sun itself is obliterated or partially blocked by a cloud or a partial haze. And if you could think of the sun's position as being in the center of a clock, sundogs can occur at the 12 o'clock position, 3 o'clock, 6 o'clock, and 9 o'clock position.
Okay.
Approximately, here's where I'm going to use my magic science. For an average person, if they spread their fingers across, the tip of the thumb and the tip of the little finger at extended arm length gives the approximate angular distance from the sun where you're going to see the sundog.
Excellent.
So if you see a hazy winter sky, spring sky, the sun is sort of obliterated, it's kind of hazy outside, look for sundogs. Hold your hand up to the sun where the sun's position would be in the sky, and position your hand at the 3, 12, 9 o'clock. At the 6 o'clock, not very often. The 3 and 9 are the most common, followed by the 12 o'clock position. And you see like a very, very miniature mock sun. It's in a concentration of light. Some people think it's actually the sun, but if you look over where the sun belongs, you'll find the sun typically hiding behind a cloud.
Wow. Yeah, they are absolutely beautiful. Now, so
And there's colors with them.
Are there really?
Yeah.
Okay.
Yeah. Same color of the rainbow, but the concentration of light is very, very tight. You have to be very observant, but there is definitely color, the spectrum of the colors as well.
Wow. See the rewards you get by just paying more attention to the world around us. Now, we've talked about rainbows, halos, sundogs. Any other special solar light phenomena that we should be aware of?
Well, for people who like to fly in planes, typically the plane is above the cloud level.
Right.
And you see some very unique atmospheric phenomena there, off of the moisture on top of the clouds.
Right.
So sort of train your eye to look for these unusual phenomena. They're usually out there. And many times when I take a plane ride, I'll know what I'm looking for, so I'll see them.
Wow. Well, John, these are fantastic. I really appreciate you just explaining these in very easy to understand details. Really want to just thank you for taking time out of your schedule to join us today. Thank you so much.
And thank you for visiting the observatory and coming back to town.
Our pleasure. Thank you.
Online coffee break.
Well, I really enjoyed our trip to the Cincinnati Observatory today. Really appreciate John Ventre taking the time to discuss rainbows and halos and other special things with us. I hope you got as much out of that as I did. If you'd like to learn more about the Cincinnati Observatory, you can visit their website, cincinnatiobservatory.org. If you'd like to leave a comment on today's topic, you can visit our website at onlinecoffeebreak.com, or you can call us at 317-862-4700. If you'd like to follow us on Facebook or Instagram, you can find us at Online Coffee Break. You can also, of course, subscribe on iTunes or your favorite podcast application. Be sure to rate us and share this episode with your friends. Thanks again for listening today. See you next time. God bless.